looks fine. You're gonna see it. Alright, here. Send it. Send it through. Yep. Huh? I'm getting in, send it through this one. Yep. You need to use it like this, or this one. Live stream. Hold on. No, that's M605. We may not get that. Go live. It's M605. Go live. Let me see. That's not true. When we get to don't receive enough information. Oh no. It's going to be this one, right? This and I'll forward it. Oh, forward it to this thing and copy. SCI33205 this. and yep, session height building again. 76005 and I'm still today is the 6th. And yep. Cloud caveat in live stream of YouTube. It doesn't go well. Oh. I'll be there. So back to the Zoom. Fertig. And yes, Schirm, Tag, my phone yeah, right. D, Warten. You know, you have to bring yes, Chrome. That's YouTube. I know. 19 election. Yes. This one. Oh no, my God. This T zoom. Right. Yeah, we are now. Mm. I can see that. Can't see through this. Okay. I can't see that. Let's take a look at the various device. This right. Protect. This one is so right. Yeah. That's the monitor in Zoom. To take care of that thing. This now. So that thing is wrong. Okay. Continue. So it's time now, okay, so that we would not what happened? Right. Yes, we have to start our lecture right now so that we will not waste our time. Okay, there's the method to leave your parents or class participation is to write down at your write down your name, okay, into the chat box in the Zoom or in YouTube, okay, as the M604 student have done. Okay, you just write down your name also in the YouTube channel and capture your screen or monitor, okay, and send it to the live chat box, okay. So that's also a possible way. Okay, I'm now trying to let you get into the Zoom meeting So okay, yeah, you can simply type your name in the chat box in the Zoom, okay, or you can also write down your name in the in YouTube channel, okay. In both channels, I have provided you the direct YouTube channel or the reflected one from the Zoom, okay. It's also possible. If I move to the GoodNote page, I may not be able to see your appearance, you're asking you're asked to enter, okay, your request to enter the class. So well, yes, some of you are waiting for the permission to get into the lecture, okay. Yeah, we will talk about the story in this one, right? In I think we have already seen the gravitational force, right, of the conductor, right? Yeah. Now ทุกคนได้ยินเสียงผมนะครับโอเคไหมครับyou can hear me well, right? Yeah. We arrive at this topic in okay, let me we arrive at this topic in okay, so that's everything is clear enough. All right. Well, yeah. Before that you have seen อย่างวันริวนะครับโอเคไหมก็คือโอเคไม่ว่า Zoom หรือว่าที่ YouTube ก็ได้นะคุณพิมพ์ที่ YouTube ก็ได้ถ้าคุณสะดวกดูที่ YouTube บางอย่าง604นะครับเขาก็บอกว่าเขาอะไรนะเขาไม่สะดวกที่จะเข้ามาที่ Zoom อย่างเงี้ยก็ไม่เป็นไรใช่ไหมคุณก็ดูที่ YouTube ไปเลยแล้วคุณก็พิมพ์ชื่อใน YouTube เพราะผมไม่เช็คที่กล้องแล้วมันเสียเวลานะผมอยากเอาเนื้อหาคุณไปให้จบ4 บทอย่างเร็วๆนะเพราะว่าเทอร์โมไดนามิกพวกฮีทอะไรพวกนั้นนะครับโจทย์เยอะนะครับปีที่แล้วก็ไม่จบนะครับโอเคyes we have before you have seen the story about signal conductor, right? And right now we are going to see something about the two conductors. Okay, there are two conductors in this scenario, and before that you have seen the FILB, right? When there is magnetic field passing through the area of that conductor, you get the induced force, right, as the outcome or the output in yes. But right now we will see more realistic situation when we have two conductors. Okay, let's say this is okay, we arrive at the slide number 96. Okay, okay. We are now talking about the slide page number 96. All right, and it's the story, the topic of magnetic force. Okay, actually magnetic forces. Okay, between two conductors, but both forces have the same. You will see at the end that both forces have the same amount. Okay, the same magnitude. So it's also possible that we simply say it's magnetic force in singular form. Okay, but actually there are two forces in this topic. All right. Yeah. Right now we have two forces. Two connectors. Let's say the upper one is connector number one, and the lower copper wire is the second connector. Okay. It may not be made of copper, but I usually say copper wire, right? เป็นอะไรนี่ Okay. นะครับพิมพ์นะครับคนมาใหม่นะครับคุณจะพิมพ์ที่ในแชทบ็อกของของ Zoom ก็ได้นะครับแล้วก็คุณจะพิมพ์ที่ YouTube ก็ได้นะสำหรับคนที่อยากดูที่ YouTube เพราะผมส่งลิงก์ให้คุณทั้ง2ลิงก์แล้วนะครับที่ลิงก์ของYouTube แบบสตรีมตรงๆนะครับจากคอมพิวเตอร์นะครับมันจะชัดสุดนะแต่ว่าเนื่องด้วยอินเทอร์เน็ตมันไม่ค่อยแรงนะมันก็จะกระตุกหน่อยนะครับผมยังไม่รู้ว่าโซลูชันที่ดีที่สุดตอนนี้ขึ้นไม่แรงมากเนาะดีที่สุดเนี่ยจะเป็นอย่างไรนะครับมันยังกระตุกอยู่นะครับวิ่ง310เนื่องจากว่ามีคนแย่งสัญญาณอะไรนะครับ and another link is the YouTube that is the result from the reflection by the Zoom. Okay, it just reflects all the vision or all the screen from Zoom, okay, to the YouTube. Okay, if you are not convenient with the Zoom, okay, you want to be free alone or for any reason, okay, you can also watch this watch our class in the YouTube link. Okay, let's continue our story. We have two conductors, the first conductor and the second conductor. Okay, the upper one and the lower one. But we will pay attention first to the force that happens at the upper conductor first. Okay, you will see later the force that is exerted that exerts on the second conductor later. All right, here let's say for simplicity at the first case, okay, we assume that the current flows in the same way, in the same direction to the through both conductors, okay, from left to right. Okay, for generality, okay, we assume that the first conductor has the current of amount I dash, okay, I prime from left to right, like this. In is denoted by I dash, okay, and the lower one, which is the second conductor, let's say it's the amount of the current is denoted by I, okay, without prime or without dash. All right, and they just use I and I prime so that we can have any value for those two amounts, okay, for those two currents, okay, and it can happen that both current can have the same magnitude, okay, it can be possible as well, okay. Back to blue note. Yeah, but we will take a look first at the force that would happen at the upper conductor, which is the number one, okay, number one conductor. All right, okay, yeah, okay, one thing I need to mention is the type of the symbol, okay, the symbol you would see here. This is the box, right, the cubic box in it's not it doesn't appear actually, but they just draw the box so that you can see some cross-sectional views in different planes, okay. They for example, this one we have three planes. This plane, right? This plane which has many dots into that, and another plane is the horizontal. มีคนต่อนะครับ Okay, another plane is the lower one here. All right. Here, okay, and the vertical plane, another vertical plane. Another plane is the one here. You can see easily the line, right? The lines, so many lines here, and that lines is the magnetic field line. Okay, and those are magnetic field lines. There are several lines, and this will be the result, okay, from the former topic that we have seen, which is the magnetic field, okay, induced by caused by the current flowing through a long straight copper wire, right? And the way we could find or determine the direction of the induced magnetic field is the use of right hand, right? We can use the right hand to find the direction of the induced magnetic field, right? In physics, we have to take care of both things, right? The direction and the magnetic field, right? In order to find the magnitude, sorry, we have to find two things, right? The magnitude and the direction. In order to find the magnitude, we have to apply the Biot-Savart formula, right? If you can remember the Biot-Savart formula, it's B equal mu 0 I, right? B equal mu 0 I and 2 pi r, right? That's the Biot-Savart formula to find the magnitude of the induced magnetic field in several scenario, but this is the special case of what may happen related to magnetic field and current, right? Of course, we let the current flow from left to right in the upper in the lower conductor, right? Of course, if you lay your thumb, okay, in the same way as the current direction, you will find that your remaining four fingers are gonna give you the direction of the induced magnetic field, okay? And if you take a look at this cross-sectional view, you see many dots right here, okay, on this plane. And as I told you, the dot sign, the dot symbol means the head, okay, or the front part, okay, the front view of any vector quantities, right? And you see that the magnetic field will be will point at this plane, okay, at this location, out of the plane, right? Because we see the head view or the front view of the arrow of the vectors. It's the head or the front view of the magnetic field at this plane, right? And on this plane you can see the cross signs, which are the x signs. It's the rear part, okay, the rear part or the back part of those vectors, okay. There are many cross signs. It means there are many vectors around here. And if you take a look at this plane, you will see that you can see the curve, right? So many curves in on this plane, right? And they also provide the arrow, which means the magnetic field uh, uh, in this way, okay? But there are many lines, okay, not a single line. Okay, it depends on how far you it depends on the location or how far you are from the lower conductors. Okay, in now you can completely see what's going on in this figure. Yeah. Um, the important thing that happens in this figure is that when you take a look at this location, okay, we are now moving uh, to the upper conductor, and we will see what will happen to the to the first conductor, the upper conductor, right? The lower one is the second conductor. Okay. At this location, you will see the same direction of the magnetic field. Okay, you will see the front view, okay, front cross-sectional view, or the rear part of that vector. And yeah, you will see that the vector at this location, the vector of magnetic field is going to point like this, okay, out of the plane. Okay, but if they draw this figure into the view, could not lose. We may lose some information. That's why they draw it in a different angle. Okay, so you can see that this is direction of the induced magnetic field. Okay, caused by the lower conductor. And as you have seen in the previous topic, F, right, is I and L cross B, right? That's the first step in order to find the induced force when there is current moving through along the copper wire, right? And in that area there is magnetic field. Okay, and yes, in this area we have magnetic field, and there is also current moving through this conductor. Okay, forget about the lower conductor. Okay, the lower conductor just gives you the induced magnetic field. Okay, but the important thing is the upper one. And when we have the current moving through the upper conductor or the first conductor, and in this area there is also magnetic field, okay, with vector B pointing out of this plane, okay, the wall, okay, this is the wall, the first wall, and here is the second wall, okay, and here is the floor, right? Okay, in this room there is a magnetic field from this wall, okay, and yeah, we are going to determine the possible direction of the induced force that may happen. Okay, the first vector is L, right? So we write down L, vector L. Where is L? Okay, L will be the vector that follow the same direction as the currents. Okay, the violet one here. Okay, so L vector will be will point in this way. Okay, in the same way as the current in this conductor. Okay, okay, in this conductor. Yeah, and that's the first vector we have to mention. And let's talk about the second conductor here, right? It's vector B, right? And yeah, where is B in this location, in this area? B is going out, okay, of the wall of this plane, right? So the B will be this one, right, out of the plane. Okay, that's the green picture, right? So, okay, and yeah, we vector, we have to rotate our fingers, first vector to the second vector, and yeah, from the first vector L to the second B, okay, you use your fingers, and you will find that the outcome, which is the value of the induced 4K, it's like this out on magnified. That's the induced force. That is at upper conductor and first conductor. All right. Well, now you are able to determine the force that is directed that is pointing towards to the right, the vector. Okay, that the force F. Okay. Now let's move to another one. Okay, to the figure 40. Same figure as block as wall. Okay, you can see the spinning circles and the field by over. All right. Yeah. Spinning you utilize by the loop. Fortunately or fortunately, that is that hits the earth and this cause the force can do by the done of the street equal to you. All right. In another okay, the form to figure so this is it's a principle to say you have you have the skin connect the lower area in the curls two curls okay is say directive from left to right from left to in the curls are separated from each other by the amount of by ID. Okay, the so they simply say I1 I2 in the former two first the I that's right is in those two vectors we can have different values for the current. Okay, portion of the that we in this topic is only on the L. Okay, okay. So but this will give you one to understand. It's easy to understand. They just draw only single in so okay, single in this make you lie. Okay, lie is significant because it just hits the conductor. Okay, and two is moving left and you lay down your thumb in the same direction as two. You are leaning for fingers. You give which is holding out the plane. They is a different angle. You see automate. If they draw to you, see. Okay, that's the given by angle is the its own okay. Is the given by the lower factors. That's okay. B number 2. Okay, B subscript will be that this is the magnetic field. Okay, given by the conductor. Okay, it's not B. It's B2 because B2 is out from the second conductor, the lower conductor. Yeah, L and the vector. That's the that of the current right is where the L. Vector B is this one is pointing out of the plane of a bit left, right to left, and here is the right, and you can get the outcome, the output as the F1. But why do they provide the script noir? The first the first okay, at the after the file number 1 as script. So yeah. Now to okay the this one is this one is of the F1 is F1 is I want because it's confluent the upper orders and it's the same for others. We don't consider this in the character difference. Okay, we consider the remains the characters are cut with the same amount of length. Okay. B will be the value because another characters be right over 1 and also side theta, but can be from this figure you will find that the angle between the vector is the angle, right? It's 90 degrees. So theta is 90, so side theta 90 is simply no, right? Right. Okay. So we need to attain this term is going to be now 1. So that is equal to 1 L and 2, right? Okay. Not we not have the same subscript K because that's given from the number from the conductors from the conductor right low. So let's to another page in here is how it yes. Oh, okay. Next, all right. Now the expected one equal RLB is not final result. So we have the final result this right. So yeah. Yeah. The results given by the sound full okay, so that we get the real final results to what we get here. Okay, right. This I'll be right in from what we have seen earlier. The correct the lower conductor for is the is is new seal and by right in case is and bigger with that is music and right that's the back to the OS from the PI builds up right yeah. Then we substitute the some result into the FI expression. Okay, we complete final expression that right. Yeah. You can the B2 is over there, right? And B2 is here. Now it's time to that location. And F1 will be on in and B2 right and replace B2 replace by the result from first new 0 and 2 right and 2 pi d. What's the reason? The reason why we use 2 in case because 2 is the magnetic field caused by again that's it's called the okay still I know try to so we have well it's going to be made like this in different location that's the so the method would be computed from to from idle yeah so we have to for one and after it's copied or called math project I have using how I do living you know at the local and so you have new 0 and 2 and now the n divided by 2 pi d. Alright, that for result in this green result is what can function is give the y equation the next here. That's the first use. It's the first friends. Alright, it's not this the okay the first factor. To make what are second there taking place at taking right because those three figures they just take a look at only for errors on output. Maybe one is there any possibility now use it first error at the low ranker at the second conductor is also the answer is there is also induced for taking place at the low ranker second conductor. Okay. And if you use it in order the life of the first answer the number 4 free I give you here that equation free where you have two conductors in that's only need you friends so that you can easily and that one right first yeah that's the I1 and here is I try to correct in yeah you have the induced if you like this let's say the start from first conductor okay it will write that straight to the conductor or I'm making how my minutes use we'll see whether this, how draw for what happen at the conductor. All right, we need to find in the first is I would be I would and without at the second conductor will be at the second conductor but vector at the second vector already at the second conductor E1 but ready to give right. And this you find that the L is some here right is pointing from right is vector and now the vector B will be the pointing into this plane right to this plane and B. But our task is find this was you have turn or your focus L to be from the first vector to the second vector in either you use right hand you're gonna use it first pointing at this okay that's the F now before that's the first at the first of the upper conductor action pointing outward right but this time at the low we have the pointing outwards the direction even the current flow the same way in direction okay from right yeah with this configuration the upper has the first point word and lower has the first pointing upward so we good this is the type of attacks this is speak they are the first type to keep or make both staying close to each other right this first in yeah on page 1 to make torrents those two are the same direction in this is at the first right but we have the same configuration of connector but we let now the current flow in the opposite direction. For example, the upper one has current flowing right, but the lower one has the current flowing from right to left. Okay, those are in opposite directions. Should the force be active or not? Or what is the opportunity? This of active, it should be depend right living or something that will keep or move the same direction. So should this be active or so after you attend route to both controls, you find that input from this type of movement or section to give you the telling forces. Okay? The force will be will will point in the opposite direction. Okay, again, okay, this is F number 1, right? This is F number 2. Okay, these are repelling forces. Okay, they try to keep those two conductors far away from each other. Okay, but before that, the force try to keep those two conductors to stay closer to each other, right? Okay, let's make a conclusion on page number 102. Okay, and we relationship as well to the former topic. Okay? Before that, we don't have the we don't have another conductor. Okay, we have only a single connector on the left side like this. All right, we have a single connector like this, and you there is no force happening at all, right? There's no that happens at all in this configuration when the current flows from the lower part to the upper part. Okay, the current is going upward like this, and there is no force in this at all. You take a top view to this figure, you will see that the dot turning, okay, circulating vectors like this, it represents the induced magnetic field. Okay, you use the right hand. Okay, you find that your remaining 4 fingers are going to be I'm going to give you the direction of the induced force. There is no there is not all single field lines. Okay, there are several magnetic field lines. Okay, totally you don't have induced force at all in this one. Okay, and if you want to find the strength of the induced magnetic field, you can apply the Savart formula, right? Let's move to another figure at the middle here. You have 2 vectors, and the currents on the current at those 2 vectors are moving in the same direction, are moving upward like this. Okay, and let's take a look at the top view of the figure. Okay, the middle, you see the result at the lower part here. Okay, you find that of course after you use your right hand, each corner you find that the magnetic field line is going to point like this. But when those 2 conductors are staying closer to each other, the magnetic field line will reach to each other. Okay, we combine together and have a single line of conduct magnetic field like this. Okay, it's not simple circulating magnetic field lines anymore. It's the combination of the same magnetic field. You have a single magnetic field. It's I don't know what the shape, how to say it, but it's the combination of magnetic field lines. And then, but the important physics for us is the force, because that's a potential effect that can happen in nature. Okay, the force in this case, okay, you can see that you get the dots at the center of each component, right? That's the head of front view of the vector of the current, and after you use the right hand to each connector, you find you get the active forces like this. Okay, when we let them flow in the same way. And let's move to the right one. The third figure. We let the current flow in the opposite direction. For example, the left one has current moving upwards, and the right one has the current moving downwards. This, and after you apply, let's take a look first at the top view, a cross section of the top view of those 2 connectors. You will find magnetic field line now has different manner. Okay, after you use right hand, you find that the magnetic field line is gonna turn out like this, and at the right corner. But at the connector, use your right hand is going to give you the magnetic field line in the clockwise direction. Right? This is the clockwise direction. On the right side, you have the magnetic field line turning or setting in. This one. The left one has the magnetic field line rotating clockwise. Sorry for that. I get confused. คือไม่ได้สนนะพี่ว่านึกคำพูดภาษาอังกฤษผิดครับโอเคไหมand on the right side you get the magnetic field line. Where is my mouse? Okay, you get the magnetic field lines turning clockwise. Okay, and at the midpoint, okay, the area between them, okay, you get the superposition. Okay, the summation of the force it's not be the merged version or the combined version at all. Okay, it's going to be the area that has very strong magnetic field this area pointing up. Okay. After we have column flooring in different direction like this, you apply the right hand to FILB, right? FILB vector version, and you get the force to each to both corners, and you find that the force is of the repelling type. Okay, the forces are trying to keep those two connectors away from each other. Okay, it's repelling forces. Okay, they are repelling forces. ผมขออนุญาตเข้าห้องน้ำหน่อยครับตั้งแต่ผมสิ่งไม่ได้เข้าห้องน้ำเลยครับปัสสาวะนี่ขอให้นะครับ Okay, we have to leave this lecture at 11:30, right? So that you can have the break of 20 minutes according to the school policy. Okay, now we arrive at the first example. Okay, that's the first case. คุณให้ลากไปเสียเวลาเสร็จอะไรนะตอนเบื้องนะทำให้มีนว่าจะนำ Okay, yeah, the example is taken from the number 2 example 19.18. The story is the following. There are ties. All right, there are two wires. Two conductors. Let's say, okay, in horizontal way like this. Okay, two conductors, and each have has a weight per unit. Oh my god, what is that? The weight unit length we haven't talked about before. Yeah. Anyway, let's go ahead with the instruction by this example. Weight per unit length of 1.10 to the 4 Newton meter. What is that? Let's take a look at any conductors. Okay, like this. When you cut it or you consider only the part has the length of 1 meter only. Okay, the conductor may be quite long, but the weight at this location only. Okay, will be 3, right? Will be 1 Newton. Okay, not kilogram. It's okay. It includes already the gravitational acceleration of it. Okay? Weight is in Newton. So if you cut it or take a look at only one. Oh my god! Sorry. What? ฮัลโหลครับฮัลโหลข้างล่างเลยครับครับผม yeah, that's the meaning of it. Oh, sorry. Weight per unit length. Okay, that's the ratio quantity they just provide in this example only. Okay, it's not so common, but it may happen sometimes. All right. Yeah. Right. Yeah. Then we go ahead with that. The two bytes are are located in a parallel way. Okay. It has no cross section at all. Okay, according to the title of this topic. With one directly above the other. Okay, one is staying on top and one is staying at the bottom. Assume that the wires carry currents that are equal in magnitude. Okay, it means the amount of charge moving per time, or simply speaking, currents are in the same way. All right, are in the same. So in the same amount. So we can say simply that we can imply that the current on the first conductor at the top, okay, is, let's simply speaking, I1, okay, and another current, but I don't know which direction, okay, in the second, this is the first conductor, this is the second conductor. I don't know which direction is in the second conductor, but the amount of the current, let's say it's I2, right, is the same as the first conductor. Let's say it's I, okay, I2 and I1 is equal to the same thing. So sorry, I1 is equal to I2, and simply speaking, it's variable I. All right. In yeah, that's it for what may happen in this example. And let's take a look at further detail. They say the opposite in direction. Opposite in direction means the second conductor, the current should move in the opposite way like this. Okay, and that already satisfied with the word opposite directions of current.